the higher the effectiveness of the activated carbon, which is our solvent. Then from table 3.2, the result of the weight reduction also show that increase in temperature has a reduction effect on the carbonization of samples. Then we can as well see that table 3.3 also talk about the absorption capacity of the rice source carbonized at 300 degrees Celsius for naphthalene, and the removal efficiency increase with increase in concentration. We can now see that if we increase the concentration, there's a likelihood that removal efficiency of such activated carbon will increase, which we have been able to prove with our data. Then, just the same way, the initial concentration that was done for the various samples showed that removal efficiency of 63.85% at 100 mil and 66.337%, while at 150 milligram per liter, it rose again. So all these things are just pointing to the fact that the concentration, there's a percentage increase in the removal efficiency in accordance with the increase in the absolute concentration as well. So table 3.4 is also showing absorption capacity at 500 degrees Celsius for naphthalene in wastewater. The clear observation from the experiment analysis is that increase in concentration from 50 to 150 milligram per liter is directly proportional to the removal efficiency. And as we can also see from the table 3.6 to 3.8, the data obtained for the 3-ring, which is acenaphthene, the higher polyaromatic hydrocarbon in wastewater for the treatment of organic pollutants, shows that absorption capacity are higher when compared to that of naphthalene, meaning now that the higher the concentration of those pollutants, particulate matter in wastewater, the higher the level of organic pollutants that will be present there. And we've been able to show from our experimental data that using a well-prepared activated carbon would definitely provide a solution to the problem facing the environment from the angle of organic pollutants. So conclusively, sir, we were able to draw the following conclusion: that the treatment of organic pollutants in wastewater using activated carbon produced from rice husk, which is a local biomass from agricultural waste, was experimented, and based on the analyzed data and results from the research, it was observed that locally made activated carbon, when produced under standard conditions, can be from the wastewater. Then the gas chromatography analysis done on the rice husk activated carbon at 600 for both acenaphthene and naphthalene almost equal the required standard for commercial activated carbon in terms of absorption capacity. It is concluded that the finer the particle sizes, the better the absorption rates or affinity of organic pollutant, as demonstrated with our activated carbon. Then also, the utilization of, we opine that the utilization of agricultural waste as raw material required for absorption and treatment of organic pollutants from wastewater will go a long way in providing solution to the environmental pollution issue and help us to minimize waste management problem. Thank you for listening. Underneath is our references. Thank you, sir. Thank you for listening. Hello, sir. Hello.
You can go ahead.
Okay.
Go ahead.
Okay. If there's any question, we should. It's question time, sir. We are done with the presentation. Thanks for listening.
Thank you very much.
Yes.
Thank you very much.
Okay, thank you, sir.
Thank you. We have listened to the first presenter of Tech Paper this morning, and we have well, Angela, can we have are you online with everybody? Okay, it's ready. Everybody, okay. Are you ready?
Yes, I'm ready, sir.
Okay.
I'm ready, sir.
We can hear you.
Can you hear me? Hello, can you hear me?
Yes, we are. Yes.
Okay.
Yes.
Can I start?
Yes.
Can you see my slide?
It was on.
Can you see my slide?
It's off now.
Okay, thank you very much. Okay. Thank you very much. I'm very, very happy to be here. Like has been introduced, my name is Engineer Oluwadare Joshua Oyebode from Civil and Environmental Engineering Department, Afebola University, Ado Ekiti, Ekiti State, Nigeria. I'm here to present my paper titled Engineering Strategies for Environmental Sustainability, Green Societies and Way Forward Out of COVID-19 Impacts. So I appreciate the President of Nigerian Society of Engineers and the chairman, the national chairman of NIEE, Engineer E.S. Ajani, the conference planning committee chairman, and the deputy vice chairman, fellows Nigerian Society of Engineers, and all engineers and participants in the house. I stand on all the existing protocol. My presentation will take this outline. I will use this outline. Introduction. Environmental health, carbon credits, and energy resuscitation and engineering intervention require special attention for public health, greener societies, and environmental sustainability. Engineering profession can tackle copious challenges for public health and human benefits. We are at the forefront. We are part of the health team. Environmental engineers have a significant role to play in sustainability. They work to enhance the welfare, health, and safety of all with the minimal use of natural resources and paying due regard to the environment and the sustainability of resources. We can see that sustainable development goal, the major work lies with environmental engineers. When we look at affordable and clean energy, climate action, life below water, good health and well-being, all this work, environmental engineers of water, air, and soil are essential for improved and sustainable environment. We discovered that most of the time our water, air, and soil has been polluted. We have a lot of soil contamination in Nigeria, and we need to avert this for improved environment. Coronavirus disease is a communicable disease that has affected all sectors and every part of the world. Aviation industry were affected. So many people lost their job and all that. So as environmental engineer, we are part of the health team. We work in line to make sure that all this global pandemic does not persist. Due to COVID-19, international regional travel restriction immediately. We have a lot of issues. It affected accommodations, the restaurants, so many work meetings and all that. Plastic materials in personal protective equipment, disposable pharmaceutical devices, and packaging for e-commerce facilities are perceived to be a lifesaver for the frontline healthcare personnel during the COVID. Even now, we have a lot of people use face masks using the different kind of equipment. All these are very, very germane. Engineering infrastructures are required in all aspects of human endeavor. They are found at various stages of human economics and social economic life. Environmental pollution has been in existence since man began to live in settlements. In earlier days of nomadic hunting communities, the tribal group moved on when food in their current location became depleted and the area around their camp became polluted or soil. In Nigeria, efforts at bringing about a cleaner environment have relied on the philosophy of pollution control, and environmental engineers, they are working hard to make sure that air, soil, and every aspect of the nation is not polluted. It will work as in some cases involve costly measures and controversial political works has been done in that area. Environmental management plan, contingency plans and equipment that are to be used to carry out a specific work on all construction contracts should be specified in order to have a friendly environment. Strategies for alleviating flood and erosion should be implemented, supported latest technology for sustainable infrastructural development. Green environment relates to the concerns for environmental conservation and improved health of the environment. These are the different aspects of climate change that are affected. When I talk about climate change, we have sea rise level, more drought and wildfire, more evaporation, more precipitation in some places, stronger storms, and all work in so many areas. We produce green buildings. We work on so many areas. And when we talk about green buildings, it helps us to have less energy consumption, less water consumption, and we have less carbon emission. We have a lot of emission in the country, and all this have to be to work on. Methodology adopted involve literature review, inputs of environmental engineers and expert opinions and other professionals in health sector. And when we talk about the community engagement, we have to look at the government governance and financing, health workforce, medical products and technologies, especially in this COVID era, public health functions, health delivery service, and we have to have collaboration across so many system management. It involves mobilization of community partnership, inform, educate, empower, which is some of our divisions are actively working on. Diagnose and investigate, monitor health, evaluate, assure competence workforce, link to services and enforce law. Because we have three major aspects. We have work of assurance, assessment, and policy development. We need to work on this and make sure that it's well done. There must be adequate assurance, which involve assure competence workforce, evaluation, then assessment. We investigate and we put a lot of policy in place. Principles of sustainability have to be put in place with sustainable design and sustainable engineering. Adequate technology we have to be involved for processes and products. And the lifestyle is very, very jamming. From what the keynote speaker said yesterday, we can see our lifestyles affect the environment. And when we impact the environment, it comes back to us and it affects our health. Environmental health, carbon credits, and energy resuscitation and engineering intervention require special attention for public health. In this figure, it shows the greenhouse gases from waste for some countries where we have a lot of emissions, greenhouse carbon emissions in some, even in aviation industries, in homes, in different areas. In the global view, when we look at the National Greenhouse Index, so we can see that when we look at the Africa, we suffer more. And we have a lot of issues, and the global and regional trend need to be worked on so that we can have better health. And looking at Nigerian greenhouse score trend, we see the way it's going down up to 2020. Now we don't know what will happen in 2021, and we see what is happening. Global food security is also affected. When we talk about environment, the way we dispose our waste, food waste, also affect us. So we put a policy so that we can get affordable, available, and quality food. And safety is also very, very important, because when we are talking about sustainable development, we put society in the consumption of resources. How do we consume materials and waste?
Hello. Hello.
Disposal risk. What are the risks that are involved? Then we look at all that. We look at the economy. These are the plastic waste.
Please unmute yourself. Unmute yourself. Please unmute yourself.
Okay. Yes. Can you hear me? Hello? Hello? Can you hear me, sir? Alphamut? You can hear me. So basically, can you hear me, sir? You can hear me. So the plastic bottles, yes, we gather some plastic bottles, we fill them with mortar, we fill them with sand, and we use them for construction of buildings. When that kind of building is completed, they put tiles, they put plastic. You will not know that they use plastic. We are trying to reduce the number of plastic waste that will be polluting our rivers. And impact of COVID-19 pandemic on plastic waste generation, we can see it has a lot of impact because we use a lot of plastic composition, and so many things were put into that. Then for sustainable COVID-19 plastic waste management practice during COVID-19 pandemic, we have thermochemical conversion of plastic waste, pyrolysis, carbonization, and gasification, and biodegradable polymers as a potential alternative to single use of plastic, and exploring alternative vaccine, packaging, materials, and delivery options. And so all these things are put. What are the engineering strategies for environmental sustainability? Number one, adoption of environmental impact assessment of major projects. We discovered some major projects were done without EIA. Environmental impact assessment must be done. Maybe you want to work on paint industry, chemical industry. They discharge their waste into the environment. We want to cite a cement industry. It is compulsory for major projects in the country that EIA is done. Number two, planning comprehensive feasibility studies, design, supervision, and implementation. All these things are there, but we need to work in these areas as environmental engineers to make sure that there are adequate supervision, implementation, and maintenance strategies. Another thing we can do is systematic management and implementation of the circular economy. In most cases, we have linear economy where we have our waste, you use, you dispose. But circular economy, we can recycle. Some of those waste we don't want, we want to have zero waste. So we can, this can be achieved. Another thing is initiative toward designing and developing novel products. Novel product. Another thing, strategies. Number 6 is process optimization to product design.
We're not hearing you again, sir. Hello, sir. Hello.
Quality validation and policy implementation is very, very important. As engineer, placement of
I want to say, engineer.
Hello, sir. Yes. Yes, thank you. Conclusion. The engineering input through various applications within the economic development, industrialization, and sustainable development of Nigeria cannot be undermined. The economic driving forces of most developed and developing nations are anchored on bases like GDP per capita, rate of inflation, and most significantly, information communication technologies. So maintaining a biodiversity policy is also another emerging requirement within the petroleum industry and most industry, which need a lot of work. One of the most effective tools is using smart and intelligent tools for continuous monitoring of the activities and services to customers, especially where the number and the type of consumers are large. We have that, and we look at the policy. We need to continually look into reuse, remanufacturing, recycling, and the effect of carbon emissions. Recommendations. One, proper funding and adequate remuneration of medical, engineering, and environmental health-related research. We must fund any research. People working in environmental engineering-related areas, they must be well funded. People should strictly adhere to COVID-19 protocol. The World Health Organization instruction and guidance is very helpful to us at this time. The supply of cheaper internet facility is often achieved within the collaboration within the private sector, telecoms. Then development of knowledge of domain with develop information communication technology-driven economics. Promoting alternative design and engineering approach, incorporating the use of natural products in the polymers for protective personal equipments. New policy of frameworks that can assist environmental engineering need to be developed. Once again, I'm very, very grateful. I did not take it for granted for this privilege given to me to present my paper in this conference with the team Energy Sustainability for Improved Environment. It's a successful conference. I appreciate and congratulate the organizer, the chairman of the Nigerian Institution of Environmental Engineer for this opportunity given to me, for their notable achievement, drive for excellence, and great contribution to world research. Congratulations. Thank you, sir. These are part of my references. I welcome contributions, questions, comments. Thank you very much. Thank you. Thank you. Thank you, sir. That's the end of my presentation. Thank you, sir.
Hello. Please, you can go ahead.
Yes. I think I've done the conclusion. Hello? Can you hear me, sir?
Not you, anybody. Not you,
Yes,
sir. It's
can you hear me?
Yes, yes. We will ask you a question. Just hold on.
Yes,
Just
thank
hold
you.
on, please. We'll ask you a question. Question, sir. Please, the floor is open for question and answer. Anybody? Anybody who want? Question. Question.
Hello, sir. Hello, sir. This is Ogbonle Olalekan.
Are you ready now?
Okay, this is Ogbonle Olalekan. We are trying to share this. We are trying to share the slides, sir.
When you are
So
ready,
everybody, so that everyone can see. We are trying to share the slides, sir.
When you are ready, let us know. Just continue, or else we'll take another thing.
What do you go from your
Anybody questions? Anybody have questions for the man that was presented?
Can't you go inside German's WhatsApp? To me, okay. Hey, can't you go inside WhatsApp itself? My what as in I remember WhatsApp, can't we? Can we go into the WhatsApp itself where it is to move it? I want it to go. And they're saying that anytime I'm ready, because it's just to talk this for 10 minutes.
Please, please, no, please. Question for engineer Oyewole is rude. Thank you very much.
Type this, analyzing this. And one saying, I can't see go back.
Are you ready? Okay, I think we have some. Please, you can go ahead now. Hello, sir.
Hello?
Yes, you can go ahead. The slide is saying, go ahead now. Engineer Guwale, please go ahead now. Your slide is on. Hello, sir. Your slide is on. You can go ahead.
Okay.
Hello, sir. Hello, sir.
Yes, we can hear
Hello,
you.
sir.
We can hear you. Continue.
Yeah.
We can hear you.
Okay, this is Olaleko. This is Olaleko Gwale.
Yes,
Okay,
you can go ahead.
Yeah, I'm talking about my second topic for today, which has to do with analyzing the efficiency of two locally produced absorbents, which are plantain peels and elephant grass, for the treatment of food industry effluent. So I'm presenting from Bonny Island, from the Department of Chemical Engineering Technology, Federal Polytechnic of Oil and Gas, Bonny, River State. So from the screen, okay, that's the abstract of my presentation, which has to be with all parts, so summary of all parts of the experiment. So from the introduction, we can see there that sources of industrial waste can be traced to food and beverage industry, and the wastewater produced on their operation possess distinctive quality that differentiates it from common municipal waste water managed by public or private treatment plants throughout the whole world. The second slide, sir. Second slide, sir. Next slide, sorry. Next. So we can see we talked about some characterization and characteristics of all this biomass. The way they are, some of them are biodegradable, they are harmless, with the exception of some toxic cleaning products. We talked about the biological oxygen demand and other properties. So the aim itself is to produce activated carbon, just like the other one, which will be used as absorbent to extract those organic pollutants. They are all captured in my slide. Next slide, sir. So, hello, sir. So, in the past, we can see the development of all these low-cost material, especially agricultural waste, for treatment of industrial effluent or wastewater, is essential because of the high cost of available absorbents and technology involved in producing them. So going the route of the local production is very, very paramount to the research body. Next slide, sir. Next slide. So I highlighted some of the features of the two biomass. The first one being the plantain peels. The second one being the elephant grass. So I talked about that. So next slide, sir. We talk exactly, it's okay. We talk about the absorption process, which is talking about the mass transfer process that involve accumulation of substances at the interface of two phases, such as liquid-liquid, gas-liquid, gas-solid, or liquid-solid interface. Next slide, sir. So here and properly, these are the methodology we employ in carry out the research. We source for the material from markets, and some were picked at the roadside. They were peeled, that's the pretreatment now. They were sorted, peeled, dry under the sun for days, just like the other activated carbon process. They were prepared by subjecting them to washing, then drying in oven, then later pulverized. Next slide, sir. Next slide. Okay, sir. So some physical properties of this absorbent were determined. As you can see there, sir, moisture content. The formula for determining the moisture content was given there as loss in weight of sample over original weight multiplied by 100. Then for the surface area, it was captured there also. Using the formula described by ASTM method D280-33. Next slide, sir. Next slide. Okay, sir. The ash content was determined by pulverizing the sample in the furnace at 850 degrees Celsius for 3 hours, then allowed to cool in a desiccator before the weight of the ash was taken. And it is given there, the original weight versus final weight after pulverization. Next slide, sir. So you can see here some structural properties of the plantain piece and elephant grass, like bulk density, which is given as a mass of adsorbent sample over volume of water displaced. Then porosity, pore space over total volume multiplied by 100. Then the pore volume also, which has to be calculated from the product of porosity and pore. Then tortuosity was also measured. Next slide. Okay, so quality parameters. Abbreviated as DO, which was measured using the Alpha 1998 method and analyzed by Winkler method. So it was calculated thus, given the formula that is on the screen, where V1 is equal to the volume of the sample bottle after placing the stopper. Then V2 is the volume of parts of content titrated. Then V equals to the volume of magnesium sulfate and potassium iodide. Next slide, sir. Okay. You can see here, we're talking about the analysis of particle size of the plantain peels and elephant grass. The formula was given according to the one given prescribed in that ASTM also. So they has to do with subjecting the material to centrifugation and dispersion of the aggregate of sample particle size. Next slide. Okay, sir. This one is talking about the outcome of the experiment. That's the results now. So the table 1 is showing the physical property of plantain peels and elephant gas based activated carbon. Here, property like moisture content, pH, ash content, and surface area were determined. Then this table 2 is talking about the chemical properties, which include iron, sodium, magnesium, and calcium. The values are respectively given. Next slide, sir. Next slide. Okay, sir. Table 3 is talking about the structural property of the plantain peels, while the table 4 is talking about the particle size distribution of the plantain peel. They are given according to specification there. The mass of particle retained, limit of the particle size, the percentage retained, and percentage cumulative retained, and percentage cumulative passing. All of them are given. So to the next slide, sir. Okay, sir. The particle size distribution of the elephant grass activated carbon then is shown up there. Then table 6, the one under, is showing the absorption of water quality parameters of plantain peels. They were given the concentration before treatment and concentration after treatment were given. Parameters like TSS, COD, and BOD. The next slide, sir. Okay, the assertion of water quality parameters, relevant gas. So, analyzing them from the experiment table 1, from the result compute Next slide, sir. Next slide. Okay, sir. This is just a brief explanation about the outcome. So from the analysis of the experiment as computed in table 1, it is observed there that the value obtained from moisture content, ash content, and the pH and surface area are higher for plantain peels than for the elephant grass. For instance, if you take a look at the activated carbon generated from plantain peel, has a surface area of 56.7 centimeters square per gram, which is bigger than that of elephant, which is at 29.78 centimeters square per gram. It is also found that the result of higher porosity, that's 96% of the sample for plantain peel, is higher than that of the elephant grass at 91.7. So comparing the bulk density and pore volume of the two feedstocks, it is very, very clear there that activated carbon generated from the plantain peels has higher absorption capacity than that of the elephant grass. So the pH value indicate that the elephant grass generated activated carbon is less acidic than the plantain peels. And the ash content of both of them are very, very close. So for the chemical properties of this activated carbon 2, we can see that sodium, next slide, sir. Sodium has bigger metal ions in the plantain peels, while calcium has the largest value of metal ion in the elephant grass. Again, looking at the bulk density of the plantain peels, we start at 0.45 gram per centimeter cube. Is higher than that of the elephant grass at 0.33. So it helps us to determine the quantity of carbon contained in a filter of a given solid capacity during filtration process. Likewise, from the table 4.5, as explained there, we can see that the range of particle size are mostly predominant in the sample, measured between 0.393 millimeter to 1.20 millimeter and 0.0363 millimeter to 1.056 millimeter respectively for the two activated carbon. So the former, which is plantain peel, show a coherence with the sieve diameter of 600 micrometer or 0.6 millimeter used for that process. Then table 6 indicate that there's a clear concentration decrease after treatment of the water by plantain peels as opposed to the one treated by elephant grass. So from the experiment, we can easily say that plantain peels has higher absorption capacity than elephant grass activated carbon. Sir, next slide. So, okay, thank you, sir. So, conclusively, the result of this experimental finding shows that locally produced absorbents from agricultural waste have a great potential for the absorption of heavy metal from wastewater. The physical, chemical, and structural property of the two absorbents indicate that plantain peels generated activated carbon is more efficient than elephant grass. Their quality are highly dependent on the preparation method and experimental techniques. Those are the two major points from this, because you can see that the method employed during their preparation, that's from the pretreatment, and the experimental techniques determine the performance of this activated carbon when used as absorbents for treatment of wastewater or industrial effluent. So also from our finding, it is also correct to conclude that the larger surface area of plantain peels means it has significant active sites for absorbate molecule than the elephant grass. I'm trying to say that the service now, which has to be our industrial effluent, when being treated with the two activated carbon, there is a tendency for the plantain peels to perform better because of the significant active site. Okay. Then lastly, we concluded that locally produced activated carbon from agricultural waste should be used as a substitute for the commercially produced activated carbon as absorbents because they are, one, economically viable, two, cost effective, three, readily available, and four, very efficient for the removal of heavy metal. Thank you for listening. Thank you, sir. I'm done. I apologize. But it's still okay. Hello, sir. I'm done. Thank you for listening. The cracks in my head these days.
Well done. Thank you. Thank you very much.
Thank you, sir. Thank you, sir.
And elephant grass. You didn't tell us the indication. Did you just carry it out for carrying out sake? You only presented the result, and the results were presented in table and not in graph. I expected that you have maybe the PS standard limit or Nigerian standard limit, a standard, a metric to compare with. Maybe we have the upper limit and the lower limit, whereby your result will fall. A graph will be shown that will show your result falling within the lower or upper limit. Then you should conclude on the is it uniformly graded or I don't know. Then the second question for the second presenter, sir. You did mention that we have clear concentration using carbon of activated carbon using plantain peel compared to activated carbon. What's the chemistry behind it? Did you check the chemical composition of the activated carbon as compared to elephant grass? You did mention so many properties, and you didn't give us the technical reasons for the properties to be better than the other. Thank you.
Question? Any other comment or question?
Yeah, good afternoon, everybody.
The properties were stated. Is stated.
Yes, I'm not here to query the technicalities of any paper presented here, but mine is just a comments. We're environmental engineers. I don't know if anybody is aware that by Sunday, the United Nations Framework Convention on Climate Change will start in Scotland, Glasgow. I've not seen that tilt towards climate change here since it started on Thursday. So I just want us to, I'm part of it anyway. I want us to see if we can challenge ourselves as environmental engineers. Is submission. I just noted something and it occurred to me. is there a way that NIE can pressurize state and federal civil service to create cadres called environmental engineers? Something along that line. I don't know if it's possible. Is a new cadre in the state and federal civil service that will not be mechanical or civil, just purely environmental engineering. Is it possible? Then again, something occurred to me again too, sir. Can NIE start pressurizing states that have not yet created Ministry of Environment in their respective states to do so as a matter of urgency because of the climate, because of the environment that is in danger right now to speak? NIE should be a major pressure group on the environment, on climate change. So many things, but let's just stop here for now, please. Thank you, sir.
Very much. Any other question or contributions? Comments or contributions? Yeah.
My name is Int'l. I want to use. Okay. Director Water Resources, Office of Drainage Services and Water Resources, Lagos State Ministry of the Environment and Water Resources. I really want to commend Okay, my name is Int'l. I'm Director Water Resources, Office of Drainage Services and Water Resources, Lagos State Ministry of the Environment and Water Resources. I want to use this time to just appreciate our colleagues that are in academic area. I want to commend Engineer Oyebode on his paper. I really appreciate you. The question, and also I just want to be sure of what you have done, most especially in your research on plastic bottles. I saw you using the plastic bottles for building, or laying. You were laying it as if you are laying a set of blocks. You fill the plastic bottles with soil, and then you laid it, and then you put mortar and all that. My question, the way I'm looking at it is that, have you finished the research on this? Can we use it to, which type of building can we use it for? Then what is the lifespan? And how long can the building stay? Or what? I just want to know what you have really done in that area, because if we get bottles out of our drains, out of our streets, and I believe that's is a plus in environment sustainability. It's part of the problems we are having in Lagos. Most of our drains, when we dredge or we evacuate, we have a lot of bottles, PET bottles all around. I believe if this work is finalized and we can tap into this particular product, I believe we will be better for it in Nigeria. Thank you very much.
Thank you very much, Mrs. Taiwo. Thank you. The question I have with you, for you, is written. Let me just read it. Maybe when you are taking it, you can now respond accordingly. The question says, from the outcome of your experiment, is there a possibility in the near future of translating the results of the experiment to production of activated carbon from the husk as a local single medium scale industry? Did you hear me? That's one. Number two, why people proving the paper proves that plantain peels based at carbon is larger than the elephant grass based on paper. Did you show the comparison? Yes, between, but you didn't show the comparison between the plantain. That's similar to the first one was asked before. Or between the comparison between the peel based on organic carbon and that of the other real adrenal carbon, the peel and the adrenal carbon. That's the questions. You have the floor to respond right now. Engineer Gole first before we take Engineer.
Okay, thank you, sir. Responding to your question, the first one about the prospects for medium scale production of this activated carbon in future and their future, what do you call it now, prospect. Yes, sir, but answering this, we all know that many researches have been done in the past in Nigeria, but we have certain peculiar problem, which has to be the follow-up on those recommendations from the research. Fine, if government can pay more attention to the local production, let's say for instance, if government can adopt what they've adopted in the oil and gas sector by establishing the Nigeria Content Board, Nigeria Content Monitoring Board, NCDMB, if they can, I would recommend that government should establish another body like that will cater for the monitoring of locally produced activated carbon, by extension, locally produced absorbent that can compete very well with the commercially produced ones. Setting up that board will address that particular issue because there will be several other, what do you call it now, sub-unit under it, which will which will take care of the feedstock session, what do you call it? Their transportation and regulating their usage. Then on the other question, sir. Okay, you are talking about comparisons, sir, of the plantain peels and the elephant grass. Talking about how does it have a larger surface area. Of course, from their physical property, we can see the value even after experiment represent that. But again, sir, I'm sorry for not providing the graphical data. But these things were done using Langmuir, BET, and what do you call it again? All these assumption also times to cross-check the one that has the better performance on another, but they are not included on the presentation slide. I'm sorry for that, sir. Hello? Hello?
Thank you.
Thank you, sir.
Please, can we have a response from Minister? Response from everybody.
Okay, thank you very much. What we did regarding the plastic bottle is that we constructed a 6.5 meter by 7.5 meters building. What we do is that we partner with civil engineering and electrical engineering department. We try to collect all the bottles. We even bought bottles. People, all the cleaners, anybody using bottle, we try to pack thousands of bottles from different places. We bought it from them, and we feel it. And the kind of building is just a residential building, a very single, it's not a story building, it's just an experiment. And the building today, we are using it in Afebala. The Fidelity Bank, the building is behind the Fidelity Bank. We collected all those bottles and we filled them, and we just something 3D view of the so the major thing that we are trying to do is to make eco-friendly, to reduce the plastic waste. It's just on an experimental stage now. And we put solar to power the building. And we discovered that people are using it. Barbing saloon, people are doing different things, lighting and all that. We don't need to bring in generator again. We don't need to bring in some other things. And the building, when they put tiles, the load is a load bearing wall. Anyway, we have no experiment for story buildings. We just ongoing research. But this one now, we can use it. People can use it with the price and everything, unless they tell you that it is very, very strong. People eat it and it's very, very strong. And we have some foreign countries that are using it. We saw videos of those things that they did. That's where we are trying to pack 1,000. With that, we are able to reduce over 4,000 bottles that's supposed to go to the ocean, to the surface water around here. I don't know whether that answered the question. So it's an ongoing research, but we are able to achieve it, and we are able to feel it, and we are able to get the building is standing now. Thank you very much.
Thank you very much. At this point, we come to the end of the technical session, and I want to appreciate everyone, the presenter, and everyone that available at the center. We want to thank you because we know coming here is part of this. Those things that the man is showing. I've seen the video, it's doable. How they used to build houses. Yes, I've seen the video before, and it's doable. And that one, like I said, will take about 4,000 plastic going to have a bungalow. And that's a 4,000 plastic PET bottle is a lot out of our drains. And that is why it's doable. That's why we need to come together and see what other people are doing all over the world. In Benue, that building, such building is in Benue. I've seen it before, and it's doable. So it is not a thing that does research, and it has been shown and can be demonstrated accordingly. Thank you very much. So I'll hand over to the chairman of the institution. Thank you.
Thank you very much, my vice chairman. It was a beautiful one. I think while we are wrapping up, our chairman board of trustee came in, and I think he should come straight to the front table.
Please remain, don't go away at back end, please. Remain.
High table. Thank you, sir. You're welcome, sir. Yeah,
Wait.
they should listen. They should listen.
Please, Chairman is talking to you. Engineer everybody and please listen.
Thank you very much. I think we are blessed with so many suggestions, research in this country. But more often than not, we are talk shops. We enjoy talking, and we are not well blessed with workshops where we really actually need to work and get results out. And engineers are not cut out for that. In fact, jokingly, one of my elders here was saying jokingly that Nigeria problems is almost seem to be beyond prayer, that we need action now. Nothing you wish that you get. This is what we need now. We don't need to reinvent anything. So many things have been resolved. Let us just localize them and solve our own local problems. But more often than not, we blame government. Who are government? We are part of them. So we should do something. For the question from Engineer Lukman Adeyemi Alafia from Lagos State, the first one you said collaboration with other environmentalists. I think that's the first question. Naturally, environmental engineering is what I call integrated engineering. And we can't do it alone. That's why in environmental engineering, every house of engineering should come. But since we are going to solve human problems, not engineers' problems, we have no choice than to collaborate with other present human beings. Tap them, know their problems, see how they think their problem can be solved, and how we can now solve it for them in a smarter way. So we have no choice than to be relating and liaising with others. This morning, I've spoken with somebody from University of Ibadan, whom I've said is to liaise with the engineer, Dr. Ajagwe. They want us to collaborate, and I've given them my word. So it's a way to go, and we are doing that every time. The second one, creation of environmental cadre. I think you were with us when I met the president of Korea. This is the major issue I raised with him. And I made him to realize that some universities are already offering environmental engineering at BSc level, not master levels now. So environmental engineers should be recognized, one, by Civil Service Commission, two, by current. And I say it should kickstart whatever it will take to get us recognized, so that if you are a civil engineer, you can equally be given a seal of environmental engineer. If you are a mechanical engineer and you are working to be an environmentalist, you can equally be given a seal as environmental engineer. So that we're equally working on it. The third one, which you said, all states should create Ministry of Environment. In fact, any state that has no Ministry of Environment seems to me that it's still sleeping. Because environment is a key word now. You have to have Ministry of Environment. If it's not standing alone, it may be joined with something else. Like Lagos State, we have Ministry of Environment and Water Resources now. And I said we are just still dreaming. We must have Ministry of Environment standing on its own, and Ministry of Water Resources standing on its own. In Lagos, Lagos is a water state. It's a water state. We must have Ministry of. I was already talking with our commissioner. He said, let us take it gently. We'll be there. We'll be there. But we need to be guided. But you mentioned one key thing: pressure group. That is lacking all engineering aspects of Nigeria. We don't know what it takes to be a political pressure group. In 2015, I took Engineer Maduka, our past president of NSC, up. I said, NSC, can't we be a pressure group? Whenever you have issues, lawyer will come and talk. Whenever you have issues, accountant will come and talk. Even our own issues, lawyer will come and talk on our behalf. Our own engineering issues. What is our problem? He said, Ajani, I'm a pressure group person, but NSC cannot go pressure group because of our members. So we need to now see how we can work around it. Can we allow division to go pressure group? You can't get it done alone. So pressure group, yes. And I want you to be one of them when it comes up. Thank you very much.
Thank you, Mr. Chairman. At this point, is presentation of certificate for the speakers. Maybe anybody and the Mole, they will do it on your behalf. You can now collect thereafter, since you are at the back end. Yeah. Please, on behalf of Nigeria Institute of Environmental Engineer, I, the chairman of the division, hereby present this plaque and the certificate to Engineer Ogunwole Olalekan Bukola as the speaker on the occasion of the 20th International Conference, so annual general meeting of the institution. Congratulations, sir. Dr. Ajagbe, come and take this one on behalf of another presenter. What is that? On behalf of the Nigeria Institute of Environmental Engineer, I, the chairman of the institution, hereby present this plaque to Engineer Oluwadare Joshua Oyebode as the speaker on the occasion of the 20th International Conference, so annual general meeting of the Nigeria Institute of Environmental Engineers. Congratulations, sir. Thank you. The photograph. Please, can we have one response from the presenter? Either.
Hello, sir.
Yes.
I'm really honored. I'm very, very happy. I'm grateful to the Nigeria Institute of Environmental Engineers for the honor given to me, for the opportunity to present my papers. I appreciate the national chairman. I appreciate the conference chairman, every member of the panel on the high tables. I appreciate Dr. Wasiu Ajagbe, all my hogas there, for the opportunity, for the privilege to present my papers on this occasion with the team Energy Sustainability for Improved Environment. I'm very, very grateful. Thank you very, very much. Thank you very much. I'm very, very delighted. Thank you, sir. Amas. Thank you.
Thank you. Have a wonderful day. Thank you. Have a wonderful weekend. Thank you. Please, I want to create your identity. Oh, Angel Kwale. Okay, please respond just 1 minute. Angel Kwale, respond 1 minute, please. How much you say?
Okay, sir. Thank you. On behalf of my colleague and myself, I want to say a big thank you for giving us the platform to present our research, the two topics. One being the analyzing the efficiency of the two locally produced solvents from plantain peas and elephant grass for the treatment of food industry effluent, and the other one being the treatment of organic pollutants from wastewater using activated carbon produced from the rice husk as a solvent. We are highly grateful, and we hope and look forward to work better with the society, with the institution after now. Thank you, and God bless her. Special thanks to National President of the NSC and the local organizing committee. And special thanks to Engineer Odukoya. We are very, very grateful, sir.
Thank you. Thank you very much. By this time, I've come to the end of the technical session. However, there is a presentation to be made by the Benin. So you have a plaque and they want to quickly present to you for your activities. So please chairman from the please come.
Thank you very much, sir. National Chairman, sir, this was on the occasion of the investiture of the Benin Chapter Chairman, Engineer Promise Nandi, all right? And that was on the 30th of January 2021 when he came on board. And so we did a presentation there that was initially handled by the immediate past chairman, Engineer Gobadia Nogai, the immediate past chairman. It's a certificate and a plaque for you, sir. What a better occasion to just hand it over and thank you for all your immense support towards our group, Edo State, NIEE Edo State Benin Chapter. On the occasion of, sir, on the occasion, all right, on the occasion of the investiture of the national chair of the chairman, Edo State Benin Chapter, we present this to you, our national chairman. Thank you. God bless you for your answer. Thank you very much. We're really grateful. We're really grateful. And we warm up to more collaborations with you, sir. Thank you, sir. All right, sir.
When you go back to Benin, express our appreciation to your immediate past chairman, Engineer Gobadia, a national ESCO member, a pillar of NIEE, somebody we hold in high esteem. In fact, I'm always surprised any activities, you just find him coming. So please give our word to him. I'm surprised he's not here today because this national international conference. And your chairman now, Engineer Nandi, Promise. Please give our words to him that we are always here to support him. Anytime he has any program, let him send it to the national. Let's see what we can do, either to be there physically or send representation or virtually. But beyond that, I think you've listened to other chapter chairmen yesterday. You have to buckle up. You see, don't be living in the past glory. NIEE Benin is now living the past glory. I don't want Delta to take over from you, overtake you. Already, the woman from Imo is overshadowing all of you. And you are the mother and everything of that section. So don't allow that. They are trying to tell us that what men, engineering is for men, can do. When you give the opportunity to women, they might overshadow everybody. Don't allow that. And I want to thank you very much. Yes. Thank you. Welcome.
Thank you. We have come to the end of this session, and then we will allow our brothers and sisters to go for their Juma prayer, and they will convene immediately after the Juma prayer. However, the chairman wants to meet the chapter chairman and the ESCO member at this meeting, and they wait for just short time before the Juma. So please, the AGM proper will start immediately after the Juma. Please come back and let us have the AGM. That until we have the AGM, we conference is not yet over. We need to come and participate and select the next set of the executive to serve you. But sir, so we have come to the end of the paper. Please, we don't want our paper sessions to end here. After this thing, you are free to contact us. Let us come up with an action plan on what we can do among ourselves and promote our deliveries within the states and the federation. So you are welcome to come with new ideas. We can take it from there. It does not end there. We don't want to dump our ideas in the bin. That is what we need to do. Thank you. Thank you, sir. The chairman, our past chairman, thank you for honoring this occasion. And God bless you. The ESCO and the chairman of the all the chapters, please can you please come forward? Let's have a small discussion before the 2 months prayer. Thank you.